in this video. Hello everybody, and welcome to the 59th video on the channel. Today will be another trigonometry video, and you might notice it looks familiar to one of my other trigonometry videos in the past, but don't worry, everything will be explained, and that's about all we have to say. Alright, now please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. Without further ado, let's move on to the lesson. For today, we don't have a lesson. We have a lesson, but we don't have a proof, since this is just explaining some more advanced things about the unit circle. Now, what I explained in my last video about the unit circle was I explained it was divided into 4 quadrants and that there were like many angles beyond 90 degrees. But that was good for basic trigonometry. But when you start solving more and more problems, you'll soon realize that the angles might not all look normal. Like there could be a negative 60-degree angle, or there could be a 700-degree angle, which will confuse many people, and I think it's good that everyone should know how this works and how to do it. So let's explain a little more about the unit circle. First of all, it's actually the radius of the unit circle is 1. That's why all the sine and cosine values are less than 1. And how the proof of sine squared theta plus cosine squared theta is equal to 1, and the other Pythagorean identities can also be proved. And it's divided into 4 quadrants, and each of those quadrants shows its respective place in the coordinate plane. As you see, quadrant 4 of the unit circle is in quadrant 4 of the coordinate plane, and quadrant 1 of the unit circle is in quadrant 1 of the coordinate. That's all that has to do is with the actual unit circle being defined. But now we're going to get into angles and how they relate to the trigonometric function. So, if we have a negative angle, that means we're going clockwise. So, as everyone knows, and I showed in my last video about unit circles, we start the angle on this line, which I'm going to highlight in red. And we start there at 0 degrees, and we move counterclockwise, up, then down, and then back up to make a full 360-degree rotation. What happens when we do negative is we reverse that. Instead, we go clockwise. So negative 60 degrees would be 60 degrees clockwise, or that would be 0 minus 60 degrees. But another thing that you'll need to know, which will also be useful for above 360 degrees, is that 0 is equal to 360 degrees, and if you add or subtract 360 degrees, the angle is the exact same. So what we're going to have is 360 degrees minus 60 degrees, and this is equal to 300 degrees. So 300 degrees is equal to negative 60 degrees. This is especially useful when having sum and difference for sine and cosine, because sometimes A might be 0 and B might be like 30, and you're going to get something like this, and it's going to be useful on how to do it. Second of all, for angles that are greater than 360, we always want to make sure that they're between 0 and 360, and the same goes for negative angles. Between 0 and 360 degrees is kind of like standard form from quadratic functions. If you remember in algebra, standard form is where you have the highest power variable first, and then going all the way down to constants. And then for trigonometry, standard form in angles is it's in between 0 and 360 degrees. So what we're going to do with 700 degrees is we're going to be like, okay, 700 degrees minus 360 degrees, so 700 degrees minus 360 degrees is equal to 340 degrees. And 340 degrees is how much the angle would actually be. So if you see something greater than 360, you'll also know what angle it corresponds to. Now in trigonometry, I'm only representing this in degrees just because most people are more used to it. But in trigonometry and above, it's more efficient and easier to use radians. As they're easier to use, they relate to the radius of the circle actually. And especially in calculus and physics, they'll make life a lot easier, especially when you're doing things like derivatives and integrals. So honestly, I think that's about it for all the stuff about the unit circle. Those are just a few more tips and tricks. And it's definitely very useful to know all of this stuff. So I think that's about it. Thank you so much. See you in the next one, and bye-bye.